Okay, so a body travels 200 centimeters in the first 2 seconds and 420 centimeters in the next 4 seconds. What will be the velocity at the end of the 7th second from start? Okay, so a body travels 200 centimeters in the first 2 seconds. So n is equal to 2 in the first 2 seconds. We are told that it travels, so S2, it travels 200 centimeters. And 420 centimeters in the next 4 seconds. So in the next 4 seconds, n will be equal to 6 seconds, isn't it?
Please.
So S6 is equal to 420 centimeters. What will be the velocity at the end of the 7th? At the end of the 7th second. So we are looking for velocity at the end of the 7th second, which is, let's say V7. All right. So using the equation for n distance covered or traveled, which is Sn is equal to U plus A on 2 times 2n minus 1. We can use this to find the initial and then the acceleration. Don't forget, this dwells on uniform accelerated motion. Okay, it dwells on uniform accelerated motion. So for n is equal to 2, we have 200 is equal to, we don't know the initial velocity, plus acceleration we don't know, on 2 times 3. Okay, let me be systematic. So 2 by 2 minus 1. Because n, we have n is equal to 2. And so we have 200 is equal to U plus 3A on 2. When we multiply 2 by 2 in order to eliminate the fraction, we have 400 is equal to 2U plus 3A as equation 1. Class, are we okay here?
Yes, please.
All right. Let's move on to when for n is equal to 6. N is equal to 6. Let me adjust my screen a bit. Oh, okay. I'm rather zooming this side. Okay, so for n is equal to 6. Azumani, your hand is up.
Yes, sir.
Hello.
Yes. Hello.
Yeah, I'm here.
Yes, sir, please. The missing, I don't understand.
Come again.
From the SN part, like from the start.
Were you with us yesterday?
No, please. I couldn't join.
Yes, that's where the problem is.
But I watched the videos and then right now I still don't understand.
You see, the whole concept is about a body traveling at a uniform velocity. Sorry, uniform acceleration. Okay. So in under uniform accelerated motion, the body moves with equal speed or velocity within equal time interval. So if I'm moving with equal speed within equal time interval, then it also means that I'm covering equal distances within equal time intervals. Please, are you okay?
Yes, please.
It means I'm also covering equal distances within equal time interval. And so once my the time interval is uniform or constant, then it means I can determine the distance I cover at every time t. So we can consider a situation where the time increases by 1 second, 1 minute, 1 hour. Okay, but we are limiting ourselves to second. So after 1 second, what is the distance covered? After 2 seconds, what's the distance covered? If the body is moving at a uniform acceleration, then it will also cover equal distances within equal time interval. And these equal distances, okay, to be covered is what this formula S is equal to U plus A over 2 times 2n minus 1 is given us. So where U is the initial velocity of the body, A is the acceleration of the body, N is the n time. Okay, we can have a varying time. So N represents the changing time. It can be 1 second, 2 seconds. So after 1 second, where N is equal to 1, what will be the distance covered? This is the formula to determine that. So this S subscript N represents distance. Sn represents distance covered in the nth time, the nth time, distance covered, okay, or using the equation of nth distance covered, or the n can be any value. So if n is equal to 1, then it means 1 second, then it means you are looking for the distance covered when at a time of 1 second. And that will be equal to the initial velocity plus the uniform acceleration of the body divided by 2 times n. And what is, Aswani, what's the n here? What's the n in this particular situation?
1 second.
1. So you put that there, minus 1. So if you know the acceleration, if you know the initial velocity, you can use this formula to find the distance covered after 1 second. If we need a distance covered after 2 seconds, n is equal to 2 seconds, then S subscript 2 will be equal to U, which we don't know, plus the uniform acceleration over 2 times 2 minus 1. So that is the meaning of the whole equation we are using. That's why are you okay?
Yes, please.
Every year, of course, yeah.
It says, yeah, so are you saying that this question, this type of question, whatever is given, the acceleration is always the same?
You say it also dwells on uniform accelerated motion. Just as
So the acceleration.
Just as the uniform, the 3 equations of motion. Are you okay?
Yes, please.
Are you okay?
Yes, please.
All right. Okay, so let's look for n is equal to 6. So for n is equal to 6, distance covered, we are told, is 420 centimeters. So it implies that 420 is equal to U, which we don't know, plus acceleration on 2 times 2 times 6 minus 1. Are we okay with the equation? And so we have 420. All right. U plus A on 2, 12 minus 1. And this is U plus 11A on 2. We multiply through by 2 to eliminate the fraction there. So what we have here, we have
140.
840 is equal to 2U plus 11A as equation 2. Now, this is equation 1 is 400 is equal to 2U plus 3A. Okay, so we solve these two equations simultaneously. If I subtract equation 1, 1 from equation 2, I have 440 is equal to 8A. Please, are we okay? If I subtract equation 1 from equation 2, this minus this, 2U minus 2 is 0, 11 minus 3, which is 8. So A would be equal to 440 on 8. Please, what is 440 divided by 8?
55.
55 meter per second square.
55.
55 or 65.
55.
Good. Akosia.
Yeah.
Okay, no comment. So that's the acceleration. Now, once we have the acceleration, go ahead.
Mr. Adria, but in the question yesterday, you said
I'm listening.
that this one, it works only when the question did not state that it's constant acceleration. So how do you know that the acceleration is constant?
I said, I said equation 3, 1, 2, 3 dwells on uniform accelerated motion, and so is this equation 2. So I even told you that this adds up to the 3 equations to make it 4. But we are usually silent about the 4th one because we don't often ask much questions about this. But this adds to the 4th equation. Okay, are you okay?
Yes, please.
So the other 3 dwells on uniform accelerated motion, meaning that if the motion is not uniformly accelerated, you can't apply them. Gloria.
Mr. Ida, please, the question was in centimeters.
Oh, thank you, Gloria. That's nice observation. So it has to be centimeter per second squared. Gloria, thank you. So let's find, once we have the acceleration, let's find the initial velocity, u. And you can use any of these 2 equations to find the initial velocity, u. Help me, 5 minutes, help me get that. Start work. Akosia, are you true?
Yes, please.
Okay, what did you get for you?
117.5 centimeters
117
per second. 0.5.
centimeter per second. Okay, so let's quickly do it together to see if what Akosia is giving us is true. So we are free to use either equation 1 or 2. If we use equation 1, 400 is equal to 2u plus 3a. So we have 2u is equal to 400 minus 3a. Acceleration is 117. Check, is that acceleration? Acceleration is 55. Okay, so let's put it in. What is 3 times 55? What is 3 times 55?
165. 165.
135.
6.
1, 6.
Okay. All right. So let's 100 minus 165.
235.
Pardon?
235.
So u is equal to 235 on 2. And that will be 117.5 centimeter per second. So what it means is that if once we have the acceleration and we have the initial velocity, we can find the velocity at when n is equal to 7 at the 7th second. Okay, so using the first equation of motion, v is equal to u plus at, n is equal to 7. V will be equal to u, which is 117.5 plus 55 times 7. Please put them together for me. Today, I also brought my calculator. Yesterday, along the line, I didn't like the value you gave me. So I brought my calculator. Yeah, your hand is up.
You get 475 centimeters.
Okay, yeah, let me test with my calculator too. 0 plus 117. So 502.
0.5.
So 502.5 centimeter per second. Please, are we okay? Are we okay?
Yes,
Yes.
please.
Yeah.
Hello.
Please, the question says, what will be the velocity at the end of the 7th second from the start?
Okay, so we are looking for the final velocity at the end of the 7th second.
Yes. Yes, from the start.
From the start, it means when our initial velocity is 117.5.
Okay, so let's say in the question we're given the initial velocity at 0. Do we have taken 0?
No.
No. The
question
body was from a rest.
The question didn't say so. Please listen to the question. A body travels 200 centimeters in the first 2 seconds and 420 centimeters in the next 4 seconds. what will be the velocity at the end of the 7th second from start?
Yes, I'm saying if you are given a question and the question says that the body was from rest,
Then
or your
initial
U
velocity,
is zero.
yes, your U is 0.
Okay, thank you.
Okay. So when the question goes like start from rest and comes to a stop, okay, comes to rest, meaning these terms indicate that either the initial and the final are 0. Another hand is up. Yes, Gloria, I saw you.
Mr. Dia, please, can you use any of the equation of motion? Like, can you use the second
Yes.
or third one?
You can use V squared, okay, is equal to U squared plus 2AS. Yes, I did that. When you use that, okay, let me explain something to you. Then I take it
Mr.
over.
Dia,
Hello.
please, when I used that one, I got a different answer.
Yes, I know. When you use this, okay, what it means is that for us to have at the second, a distance of 200 centimeter covered, at the 6th second, a distance of 420 centimeters covered, it means the body would have to start with the initial velocity of this and accelerate at a rate of 55 centimeter per second. And you have this indication. You have this. So when the body starts from 117.5 and then accelerates by 55 centimeter per 55 centimeter per second per each 1 second, then you have the body covering a distance of 200 centimeter within the first 2 seconds, and then 420 centimeter within the first 6 seconds. Now, if you have the other one, okay, if you use the other equation, yes, you also get initial velocity close to this. Those of you who used it, what did you get for the initial velocity? I'm sure you had
I got 115.
good, 115, close to this. But what it means is that in that case, the body must be decelerating. Okay, the body must be decelerating. That's why you got A to be a negative, meaning that when the body starts with the initial velocity of 115, close to 117, and decelerates to that value, you also get the same distances covered within the time. That is why you got that value. Please, are you okay? So that is another option.
Mr. Dia,
Yeah.
Mr. Dia, so if a teacher is marking, would the answer be marked right?
If Mr. Dia is marking, I'll equally mark you right for using that approach. Are you okay?
Yes, please.
I considered both situations and saw it. So if a teacher is marking and you use that, you will equally be marked right. That is why I said that this equation is also more or less like the fourth equation of motion. That is the main reason why after getting U and A, I use equation 1 to get the velocity for the 7th second. Please, are we okay?
Yes, please.
Yeah. Amma.
Sir, please. So it means that our answers doesn't need to always be in meter per second.
Oh, you see,
It can be different units.
Here we are not converting. We are only using what they gave us. But Amma, if you also convert from centimeter to meter and then express your final answers in meter per second, Amma, you are not wrong. Are you okay?
Okay.
Yeah. All right. Please, have you exhausted your questions? Okay, then let's move on. Do I clean the board?
Miss Stacy, I think I have a question.
Okay, last one, so we could move on.
Please finding the final velocity. Can you
Mhm.
do like A is equal to the V minus U out of T?
Finding the what?
The V, final velocity.
Uh-huh.
Can you use the formula for finding acceleration? Then you make
Oh,
it
Amma, that's what we've, is that Amma?
No, Akosua.
Akusha, that's what we've used here. Don't forget this
Ah,
equation.
okay.
Are you okay?
Yes, please. Thank you.
All right. Do I clean the board? LP, our last question. LP, our last question.
Yes, please.
Please, it's not a question. Please, I can't see the board, under the board, like down.
Oh, I can see you. LP, I can see. But all that I have here
Okay,
is.
sir. Okay. Thank you.
All right. Can we move
So
on?
please, no, please. So please, I
Uh-huh.
have a question.
Nana Kuya.
So it's assuming.
Okay.
Yes. So please, with they said the first 2 seconds is 200, like the body moves in 200, like 200 centimeters.
200
Then the next
centimeters.
6 seconds. So it doesn't mean that
The next
total seconds to be 8 or.
Hold on. The next 4 seconds. So if we've covered the first 2 seconds, and the question is about the next 4 seconds, then certainly it will be the 6 second. Okay.
Yes.
So we are looking at the distance covered within the first 2, and then the next 4. So n is equal to 2 seconds and n is equal to 6. After getting the acceleration and initial velocity, then we find the final velocity at the 7th second. Last question. I think, in fact, this must certainly be my last. And who is here? Gloria again.
Mr. There is no a question. Please, I wanted to see the right side of the board I'm capturing.
The right side, as in this side, or?
The other way.
Okay. Are you fine?
Yes, please. Thank you.
Okay. Let's continue from where we ended yesterday. So yesterday we were looking at vertically upward motion. Vertically upward motion. Then we derived some standard equations. Some standard equation or formula. And the key or the chief concept under vertically upward motion. The chief concepts under vertically upward motion is that when a body is projected vertically upwards, let me write some notes. When a body is projected vertically upwardly, the body's final velocity is equal to 0 or is 0 when, on what condition is the body's final velocity equal to 0?
When the body
reaches its height.
Okay.
Greatest height.
Okay, when it reaches the maximum or the greatest height. So all that we are saying is that at the maximum height, V must be equal to 0. So if V must be equal to 0, then using the first equation of vertically upward motion, we'll have 0 to be equal to U minus GT, where T will be equal to U over G. This expression of T is the time taken to reach the greatest or the maximum height. So T max. So if you are asked to determine the time taken to get to the maximum height, all that you require is U over G, and you'll be free. If you are asked to determine the time of flight, T of flight, what would that be? What would the time of flight be?
U over G.
So twice this. And for the sake of those of you who are not here, if a body is thrown from this level, it will go, when it gets to the maximum height, it has to return. Okay, so at the maximum height, V is 0. So if it takes T seconds to get to the maximum height, it will take the same seconds to return back to the ground. So if I'm looking for the total time used, and that is what we are calling as a time of flight, then it will be equal to 2 times the time taken to get to the maximum height. 2T max. Please, those of you who are not here, are you okay?
No, please. Can you please go over?
Yaba, are you there?
Yes, please.
Otubia Santi, are you there? Local.
Yes, please.
I wish I could mention the names of all, but let's. So this is what I'm saying. As many, a body was thrown from this level, from the ground level. It went, then reached this maximum height, H max. Okay. At the maximum height, final velocity is 0. So if when its final velocity reduces to 0, it cannot move up again. It cannot move any further. It would have to return. What I'm saying is that if it takes T seconds to move from this point to the maximum height, it will take the same time to return back to the point where it was thrown. So if it takes T seconds to get to this level, it will take the same time T to come back to the floor. So if you are looking for the total time taken, total time during the flight of the body, it will be equal to T plus another T. So T plus T giving me 2T. Are you okay?
Yes, please.
Good. Then what is the total distance covered? Yaba, what is the total distance covered during the whole flight? Yaba, what's the total distance covered during the whole flight? Yaba, you've gone to sleep. Okay, please, class. What's the total distance covered? Anybody?
U squared out of G.
Come again.
U squared out of G.
Yes, yes. We saw that the total distance covered will be equal to U squared out of G. For the sake of those who were not here, you see, it will get to the maximum height. So if I'm looking for an expression for the maximum height, H max, which is the maximum height reached. How do I get that? Using equation 2, V squared is equal to U squared minus 2 JS. But we are changing this S because over here we are talking about vertical height. We use S for displacement. And so because we are talking about vertically upward motion or downward motion, we are changing the S to H, height, meaning vertical height. So when the object gets to the maximum height, this V is 0. So 0 is equal to U squared minus 2 JH. As help me make H the subject. Quickly help me make H the subject. Hello. H will be equal.
Please, I cannot see.
Oh. Okay. H would be equal to, when I send this to the other side of the equation, I have 2GH equal to U squared. H therefore is U squared on 2G, meaning that the maximum height reached, which is the H max, is equal to the square of the initial velocity divided by 2 times gravity. If I'm looking for the total distance covered, which is from here to this point, it takes a distance H max, which is U squared over 2G. Then it gets to the maximum height and falls, okay, back to where it was initially thrown. It will cover the same height. So this is H max, this is also H max. So total distance covered will be equal to H max plus another H max. But what is H max? H max is this, U squared over 2G. So I have 2 times, or I have U squared on 2G plus another U squared on 2G. And this is the same as 2 times U squared over 2G. Okay, 2 and 2 will cancel out. Therefore, total distance will be equal to U squared on G. All is well.